Well, like we said, it's about greatness. Greatness is not just results, it's a mindset. It's a determination we're going to take our talents and our energy and our money and do things. We're talking about here technology to go to commercial detection of oil and gas, which goes to commercialization or to cleanup activities, mosquito habitat, finding nurdles, improving your backyard in West Houston. It's about greatness, and I'm just really proud to be a part of this community. I was sitting here wondering, these introductions are getting increasingly tough. Is everybody a giant and great in their field? Well, guess what? Here they are. And I want to introduce our next speaker, Rustom Mody. When I retired, or one of my colleagues retired, actually, I gave a talk, and I dubbed people my age and Rustom's age as the greatest generation. In my time frame at that time was 1980 to 2016. I elaborated all of the things that had happened, all the technologies in the upstream oil and gas business. And I started talking about that personally, and I thought, of the people that I've known for that period, certain names keep popping up, and Rustom Mody is certainly one of them. When I was a very young engineer, I was working on oil field cementing, and they said Rustom Mody is the one to talk to. And that was the case, that is the case to this day. And one of the conversations I had from time to time with Rustom was big data. What about big data? When that term became prominent, we were all going to meetings and trying to figure it out. And I had several conversations with Rustom. And Rustom's advice was, big data is showing us a lot of things. It makes a lot of connections, amazing connections. But you know what? Most of them we already know, because we've done this a long time and we've observed these. Well, as Dr. Charles said, sometimes you get enlightened when you get a little more involved. Because last time, I think we were talking about this agenda, I talked to Rustom and I said, anything in big data? And he said, yes, it is now adding value. So that's the title of Rustom's talk, Big Data, it is now adding value to the oil field. Rustom?
Before I start talking about big data, I got a short announcement to make. I don't know if you all caught it or not. Dr. Lumsden mentioned this morning that Pumps and Pipes is starting a new initiative in Scotland. So I want to just give a little introduction to that engagement, because I've been involved in helping them set it up over there. It's sponsored by the local Society for Petroleum Engineers. It's led by Mr. Ian McIntosh in Scotland. And it's going to be on February 19th of next year, the first annual meeting in Scotland. I know we established the one in Stavanger a couple of years back, and it's really taken a lot of traction. A lot of interest globally on what Pumps and Pipes have been able to achieve. And it makes so much sense to a lot of people. But it takes a while, and they're always looking for guidance from this particular organization. So Dr. Lumsden is going to speak the night before at the annual dinner, and I've been asked to speak the next day. So I just want to give a quick intro to Pumps and Pipes Norway. Here's a little brochure they put together. Like I said, on February 19th, you could go to the website and check it out. And if you happen to be that part of the country, please join us, okay? With that, I'm going to go ahead and talk about big data. Honestly, I have no idea what big data means. And I've asked a lot of people in my own organization, what is big data? Really what it means is a lot of data. That's what big data is. It's not a fancy term. And it sounds pretty impressive, because every time you see senior leaders, we're going to do some big data. What does that mean? Honestly, it means nothing to me. It just means a lot of data. But what I'm going to show you later on today in my presentation is the value you create from that information. That's where the essence of the whole thing is about. So I'm going to have some examples in the oil and gas industry on creating value through big data. But going back 4 years to 2014, I was at a Sierra conference in Houston, where most of the oil ministers, executives meet. The price of oil was $107. The biggest complaint every CEO had? that they were not making money. $107 a barrel. 6 months later on, it dropped to $25 a barrel. You think they were making money at that level? No. As an energy service company, it was very critical for us to have a wake-up call that we got to do something different to be innovative. Because the business as usual is no longer going to work. And what I mean by being innovative is the fundamental cost of producing per barrel of oil has to be dropped down considerably. In those days, offshore, you needed $70 a barrel of production to be profitable. In unconventional shale business, it was around about 45, 50. So none of those businesses were productive at that level. So we have to figure out technology to bring the price of oil down in terms of production costs so our customers can make business. And that's when we realized as an industry that we got to change the way we were doing things. And if you look at all around us, most of the industries were already on a digitization journey. Automotive, aerospace, medicine, we were late entries into that because of a wake-up call for us. We had a lot of initiatives individually within companies, but not really a grandeur approach for the whole energy industry. So it was a wake-up call because most of the industries, when you have a digitization journey you go through, it is synonymous to increase in productivity for some shape or form, okay? If you look at retail, look at automotive, things like that is increase in productivity. So the industry was on a digitalization journey. So next question I ask myself is, what's digitization? And again, I can have 3 CEOs or 3 senior leaders and I get 5 different definitions. Same thing with Beat. What does it mean? I'm going to bring you down because it took me a while to realize what it means, okay? So I'm going to bring it down to that. So having said that, one thing we were very rich in the energy industry was data. We collected data left and right. And everybody kept that information about the reservoir very like a proprietary information. But guess what? We never did anything with it. We collected it, but we didn't know what to do with it. Because you know why? Before 2014, we didn't have to. We are busy making money, $107 a barrel. And because of that, the strategy within the industry was very weak overall. And it was ill-defined, okay? So what is digital? It's not a gadget. On the left-hand side, you see, I don't know what model, it must be 2060 model, but there's a smartphone on that. Does that make it digital? I don't know. A lot of people may say yes. I mean, it can take me from A to B without getting lost. On the right side, you see a Tesla fully loaded. Does that make it digital? I don't know. So the question is, what is digital? I'm going to keep it very simple. When companies say they're going on a digital transformation journey, all they're trying to say is all about data transformation. What digital does is allows you to collect information, data, much more rapidly. But that's not transformation. You're just collecting a lot of data. What you do with that information to make decisions that add value is a transformation we're looking for. So if you look at examples we heard today from NASA, from medicine, it's all about collecting the data. But what you do with that information real time in terms of making decisions, like in the surgery, a lot of information being communicated to the surgeon. But what information he uses to make a decision is what a value creation is. So digital transformation, to put it simply, is nothing but data transformation. Once that's clear in your mind, then everything you see around you is, guess what, you're collecting data. What you do with it is what's critical. So the tangible components of digital transformation are what? IoT, you heard a lot about the Internet of Things, connectivity with sensors in refineries, in every industry you think about. Sensors, cloud, the edge, big data, But what you do with that information through, say, machine learning or data transformation or artificial intelligence, that's what creates value. The rest of the thing is just noise you're collecting, the information you're collecting digitally, and transferring the data information to value-added decisions. That's what's critical. So digital can add value through innovation. And there's a story of big data in all this. The information that you collect, it better be secure. Just 2 days back, you heard about Marriott hotels losing, I don't know, millions of information. Again, whatever you put in any information you collect, better be secure. It has to be nimble. It has to be cost effective. It has to be safe to use, and it has to be scalable. That's the fundamental building blocks of a transformation journey through innovation. One of the things we see, the potential of digital transformation is that there's a potential of reducing 50% cost in the industry through increase in productivity. Because we've seen there are other industries, we benchmark against other industries. There's a potential of as much as 50% reduction in cost. So what does that do? It reduces the cost of doing business for our customers so we can all make money at the same time. In the energy industry, there are certain drivers and challenges our customer have. So before you start looking at data, or big data as you say, you got to know what you're going to do with the data. How does it add value to your customers? Both internally and externally. Value creation doesn't have to be externally. It can be internal value creation, or external value creation. In our business, it's all about the optimal drilling completion, reducing the cost per barrel of oil, reduce well cost by 50%. Okay? Things like understanding, eliminate data silos, increasing uptime, improving the utilization of your assets, reducing the repair cost, reducing non-productive time. All of that leads to the reduction in cost per barrel of oil produced. That's the name of the game. How we do that is by reducing costs all around us. So the focus of big data is we have so much information on our assets, on our technologies, on the reservoir itself. What you do with that data is what's critical. So one of the best examples I can give you is one of our senior guys said, okay, we need to start hiring data analysts. Okay, so what do you do with them? Oh, we give them all the information we collected, the data, and tell them to mine it, find out patterns in the data, and then we can make value out of it. Okay? The way I look at just hiring data analysts to do your mining of your big data, which is nothing but storage, a lot of information, is like asking a miner to mine for gold, and a miner doesn't know what gold looks like. So what are you going to get? A whole bunch of coal. So you got to have the subject matter experts embedded in a team with a data analyst, and together they can look at patterns of information. All data analytics is all about looking at pattern of information. Certain patterns of data that make sense. Okay? And the way I was explained from data analytics is looking for patterns in data. When you talk about machine learning, which the next level of it is aligning different patterns of data and making sense out of it. And the next level is artificial intelligence. So there's a lot of science beyond all that. But the subject matter experts have to be embedded to understand what you're looking for. So in the promise of digital or big data analytics, or what do you want to call it, is all about reducing cost of oil produced. Then as you move up the chain, is optimizing your assets, reducing your operation cost. When you reduce your operation cost, you reduce the cost of doing business, that reduces the cost per barrel of oil. Reducing human intervention. All industry is a high-risk business. So whenever we can automate things, which is on an aggressive journey right now we are in, is going to reduce intervention, which can improve the overall safety of your folks. increase revenue to reduce inventory costs. At the end of the journey, I don't think it's the end of the journey, as you progress up through the path, it's all about real-time access to information to make decisions. That's what it comes down to. And that's what big data allows you to do. It helps you understand the information you collected, make sense out of it, so you can make some value-added decisions in your organization. So, how does it work when you talk about analytics? There are many steps. It all starts with data. That's your big data. As it grows bigger, it becomes bigger data. That's what it is. It's information. That's what it is. Okay? So you got to be able to go back and look at it and analyze it in different stages of it. Eventually, once you find patterns in your data, you can start looking at that information and start making predictions as you go forward as to potentially what can happen. Okay? Because it's all about supporting your decision making. That's all that information is. If you don't do anything with it, it's worthless. You may be collecting a lot of information, a lot of sensors, but if you cannot make appropriate decisions in a timely manner, it's not worth anything. Eventually, whatever you do in terms of analyzing the data, it has to lead to an action that creates value. Without this particular piece of it, even if you're able to make a decision and you don't do anything with a decision, it's not going to create any value. So it has to be an actionable decision at the end of the analysis of the information you have. And so keep in mind, this particular pie is constantly changing. The data is getting bigger and bigger and bigger day by day. Okay? So that's the kind of a framework that you're looking at. So let me give you some examples in the oil and gas industry. Our biggest asset is a reservoir. Reservoir that is rich in hydrocarbons. So we got to figure out, it has to go through various stages of development. From identifying what a reservoir is, to developing the field, for designing the plumbing, for constructing it, and producing it. And it's a continuous life cycle. A lot of you may be surprised if I told you that in unconventional, or let's just talk about deep water reservoirs, which takes 12, 14 years to develop, and it's a lot of multi-billion-dollar investment. You know how much oil we actually produce from those reservoirs? You'll be lucky to get 12%. 88% is left behind. When you look at unconventional shale, for example, that we hear a lot in North America, 6 to 7%. Okay? And the key thing is, if you can manage your reservoir through a proper coordinated transfer of information through its life cycle. Right now what happens is the information collected in field development barely gets transferred to the individual who designed a well. Same thing, there's not a seamless flow of data in organizations. But if you have a platform on which you can flow data stream seamlessly across the organization, by creating value at each stage, you can see a tremendous benefit of that information. Because instead of analyzing the data all over again, you're filtering the right information as you go down the process, and eventually it's going to lead to an optimized production profile of a well. That way, instead of leaving 12% behind, instead of producing 12%, if you only produce 14%, that's millions and millions of barrels of oil. So understanding the reservoir. And that's what we at Baker Hughes, it's a GE company, we are doing very extensively the analysis of this reservoir to get a maximum production out of it. That's the name of the game. This is one journey we are on right now. Another example is transferring data into common insights. Here's just an example of a data on a particular well. Okay, it gives you the profile of the formation, things like that. And that particular data is then transferred into information. And basically, we got to understand the makeup of the reservoir. And a lot of times in wells that you have, you produce a lot of water. along with the oil. So when you produce water with the oil, you cannot just separate the water out and dispose it out. There's a lot of cost associated with producing water when you want to produce oil. That means you have to do a lot of processing on surface before you can dispose it. So why not just leave it behind? If you just leave it behind and produce oil, it reduces the cost of producing oil. So understanding the information that's up here by doing appropriate analysis of the information, looking at patterns as to which formations are doing what, you can optimize it where most of the water is left behind and you're only producing the things you need to. Tremendous value creation by interpreting the data from wells, by correcting your production processes, and improving the overall yield at a lower cost. Another example is in a lot of deep water wells, a lot of onshore wells too, we run what is known as an electrical submersible pump downhole in the formation. What happens is the oil produces naturally up to a certain point where the pressure of the oil produced is higher than at the surface. So the oil flows naturally. Over the years, the pressure decays down. So that means you have to put some artificial means of pumping the oil out. These are called electrical submersible pumps, and they are ran over the entire reservoir with multiple hundreds of wells in it. And they run independently. In the past, we analyzed each performance of the pump individually and manage the production, but not understanding how they are all interconnected in the reservoir. And oil is not something that you just have a big bundle of it and you put a straw and suck it out. Oil is spread in the granule of the grains, and they flow naturally into the main bore from which you produce. So in this particular example, we had 75 different electrical submersible pumps dispersed in a particular reservoir. Like I said, each one was used independently, producing data. We tried to collect all the information and we networked the entire reservoir together to understand how it was performing and try to scale down one, ramp up the other one, depending around the reservoir to get the maximum production out of it. And that requires a lot of analysis of information and everything. With the computing power today we have, we were able to reduce the cost and increase the maximum yield of the reservoir. This is strictly by only analyzing information we already had. So the potential is tremendous going forward. Like I said earlier on, instead of just producing 12%, if you can produce 14 or 15%, you're talking about millions of barrels of oil. Okay, this is just one example of how understanding the information you have and making value-added decisions is how you create value. Okay? Another example is, this is an unconventional well. When I say unconventional well in North America, I'm talking about shale. There's a lot of fracking. I'm sure some of you must have heard the term fracking. These wells produce, for the first 12 to 18 months, the production goes up and it drops down gradually. Within a couple of years, you're going to drill some more wells. So you continuously drill wells because that's what it is. A shale formation, very hard formation. Oil doesn't flow very equally, properly, but you got to keep on drilling more and more on wells. Here's an example of a cluster of wells that were drilled horizontally. Okay? On one pad, they can drill multiple horizontal wells in the formation and frack it to produce it. But what was happening was, because some of them were so close, there was interconnection between the wells. There was a bleeding of one well to the other. We called it the parent-child relationship. And that reduced the overall production of the well, collectively, because it's bleeding from one another. So the information we had collected, we'll be able to analyze the placement of the wells to avoid this interconnectivity across wells. And just by analyzing information, you can see we optimize the production. I call it low-hanging fruit. Just understanding, identifying the patterns of which wells were interconnected and which were not. You can start looking at patterns and start avoiding those mistakes, but a proper placement of the wells to increase the overall production. Another example how analysis of the information can create value in your life cycle. Here's a very good example that I will end with. One of the divisions within a company, we manufacture turbo machineries that are used in the downstream business in refineries. These are big, large turbines that are sold to customers, and periodically they break down. A lot of downtime. So if ever we can stop the equipment from breaking down and repair them before failure happens, it reduces non-productive time. That's all the customers are worried about, is reducing non-productive time. They don't care about equipment. They don't like downtime. So with all the information, most of these turbines have hundreds of sensors built into it. We collect a lot of information and everything on it. And we monitor the performance of these turbines during its lifetime. Aerospace has been doing it for a long time. We have an iCenter in Florence, one in KL, and one in Houston. So we monitor turbines installed globally 24/7. And we have algorithms developed by which we can predict failure earlier on and take the proper appropriate actions to repair it or replace it very quickly so there's not a long downtime. That's called predictive analysis. And this happens over the years of information collected and analyzing information. So we have this iCenter in 4 different parts of the world. The whole reason being is get the information, analyze it, and predict the failure or downtime, repair it before it happens so the customer doesn't have non-productive time. That's all the value creation is. But what that leads to is completely a different business model. Now we don't sell our machines, turbo machine. We just provide a service to our customers by saying, yes, here's a turbine, you just pay us by operating cost, how many hours it runs. For every hour you pay us so much. You don't have to buy a turbine, we'll give it to you, you just pay us on a monthly usage of it. Completely change the business model. Because now we know that we can guarantee them no downturn, and we can make a much more bigger premium on it, and it becomes what you call an annuity. Once a customer rents it, he has it, he doesn't have to worry about downturn, we take the risk, but at the same time, it's a calculated risk we are taking. Because we know now how our equipment will perform, we know how to repair it in a timely manner to avoid the downtime. So there's another example of that. And the way we do it is through a digital twin. Every turbine we have out in the industry running today has a digital twin that we monitor at the same time, that we do simulation on it to see how it's going to perform. More and more the industry is going towards developing digital twins. We have digital twins developed for major rig sites. The entire rig is modeled to know how it's going to perform over time. What a digital twin does is allows you to simulate or predict the performance of the equipment in the future because it's monitoring the same way as the current equipment is. So I don't see why we cannot have a digital twin for every new heart we put in, or every person down the line, okay? In terms of its sensors and everything, knowing how patients are performing because we have a simulation model over here. So digital twin is a big thing that the industry is going at. It's all about seeing the present and predicting the future. That's all digital twin is all about, okay? So that's another example of how we are going forward. The other critical thing that people really talk about digitization, analyzing data, predicting failure, is it improves overall safety record. Okay? This example of, from the information I've been able to collect, is through automation and through robotics, neurosurgery, and spine surgeries. There's a 5.3% reduced cost by using robots to perform the surgeries, and a less likelihood of follow-up surgeries. So automation, robotics, all that things are here to stay. But all that does is helps you look at information and make value decisions going forward. And the biggest benefactor of digitalization has been the aerospace industry. The airline incidents per million flights have dropped to 4 to almost 0.5 through automation. But if you think about automation in a cockpit, is what? It's collecting information from the sensors, and through machine learning, or what do you want to call it, decisions are made automatically. The pilots are there just to make sure they step in when they need to. I remember in the early 80s, 70s, there were 6 people in a cockpit. Now only got 2. Because everything is automated. And that's where our industry is going forward to. At the rig site, offshore, onshore, you name it, is completely getting connected digitally. But I can sit in my office in Houston and monitor a production well offshore Nigeria, make some changes on a valve downhole 30,000 feet deep, and control the production of the oil remotely with the information I'm seeing on my screen to make the appropriate actions. Or like the example I gave you on the submersible pumps, one person can sit in the office, monitor 65 units, and control the production to get the optimized result from the reservoir. That's what the future is. And coming back to big data, it's all about the information you collect, but the value is from what you do with that information. So when somebody uses the term big data, don't get pretty impressed by it. It just means a lot of data, okay? The value creation is what you do with that information. Having said that, I would love to end with this slide. That's Thomas Edison. You see a lot of fancy PowerPoint slides, everything on big data or what can be done with it. But at the end of the day, it's all about execution. What you do with the information. Just because you collect it doesn't make you rich in information. What you do with it is what the whole value creation is from. So with that, thanks for the opportunity.